Yo, what is going on, guys? Today I'm going to be showing you guys how to make this super versatile miter saw station. This miter saw station, it has integrated 3D printed T-tracks. I also designed and 3D printed a stop block for it. And it also has a router table. And it also has 3D printed dust collection on the back. Okay guys, so this is my design that I came up with. I wanted it to be mobile, and it basically just has a bunch of shelving built into it so I can store all my power tools. And I'm leaving the middle section open so that it can hold my shop vac, and it can easily plug into my miter saw station, and it can easily plug into the router table. I also do have plans for this if anybody is interested. So the first thing I'm doing is cutting all my pieces out. I chose to go with MDF for this build because it is significantly cheaper than plywood. A sheet of MDF actual size is roughly 49 inches by 97 inches, so I just had the people at Home Depot rip the board long ways so I could get it in my truck. To ensure that my cuts are straight, I'm just using one of those Harbor Freight straight edge clamps. Be sure to wear a mask when doing this, cause MDF kicks up a ton of dust and you don't want to be breathing that in. For a long time now, I've been using one of those mini Craig pocket hole jigs, and I really don't like it. So I decided to pick up this general pocket hole jig off Amazon to see if it was any better. And it came in this nice little kit, and I wasn't really ready to spend $100 on a new Craig pocket hole jig, so this was a great alternative. I will leave a link to it down in the description below. This project required a ton of pocket holes, so it took some time, but I got it done. I started by drilling 6 pocket holes on both sides of the board on all 5 panels. Once all the pocket holes were drilled, I decided that the easiest way to assemble all the panels was to lay it on its side. To make sure all my panels are at 90 degrees, I just used a rafter square to check my alignment. Then I screwed all the boards together using 1 1/4 inch screws. Now that all my panels are secured and in place, I need to flip it over to the bottom side and attach the base supports and all 6 of the locking casters. I didn't have screws long enough to go through the 2x4 and into the MDF, so I decided to just countersink the screws. I attached the base using approximately 9 screws or so, just enough so that I could get it to flip over, and then once I got it flipped over, I attached more screws into the MDF into the 2x4. Here I am just pre-drilling holes for the casters, and I attached them using 1 1/4 inch lag bolts. I just used these cheap locking casters from Harbor Freight, and I used 6 of them, so it's rated for roughly 750 pounds. Now you guys get to enjoy me trying to flip this over by myself. If you guys have never worked with MDF before, it is extremely heavy. I think this is like 1.5 sheets of MDF, plus the 2x4s that are on it, and the caster wheels. It was very, very heavy. It's definitely a two-person job, but I found a way to get it done. Good. Next, I needed to cut the vertical stretchers for the tabletop to sit on. It's important to make these cuts accurate and straight so that your table sits perfectly level to the miter saw. Next, I aligned the stretchers along the bottom of the tabletop and fastened it down with pocket screws. After it's screwed in place, I can flip it over. Now I'm just checking to make sure that both tabletops align, and later I'll screw them down, but I'm not going to do that until after I integrate and build the router table into it. I marked the hole locations for my miter saw and then drilled them out so I can put threaded inserts in. This will ensure that my miter saw lines up perfectly every time. I decided to put these threaded inserts in at the bottom because I know that MDF tends to mushroom up and crack, and that is exactly what happened. So if I could do it over again, I'd probably just use a bolt washer and a nut to hold it down. Now I'm just giving it a quick test fit just to make sure everything lines up and everything fits. Now I needed to route the groove for the T-track to sit in. This was the first time I've ever routed a groove for a T-track, so it wasn't the best, but I got the job done. So, as you guys can see by the title of the video, yes, I am using 3D printed T-tracks. This is more of an experiment more than anything, just to see if it actually works. Over time, I probably will be replacing all of it with real aluminum T-tracks, but we're going to give it a try and see if it works. So these 3D printed T-tracks have the exact same dimensions as your standard T-track. And here I am just tapping them all into place. Once I got to the end to trim off the excess, I just used a flush trim saw to cut it off. For the router plate, I decided to make it out of plexiglass. For the plexiglass, you can cut it on the table saw, but I prefer to just cut it on the miter saw. And what worked best for me is just to lightly score it on the way back and then plunge through it and then cut forward. Next, I laid out my plexiglass square where I wanted to put the router table at, and I began to route the table out. Next, I just used a jigsaw to cut out the inside square. This doesn't have to be perfect. I definitely didn't do a very good job at it, but you can come back later with a chisel and chisel it and make it flat. Once I removed all the extra material with the chisel, I tested my router plate to make sure that it fit, and it fit perfect. I am using threaded inserts in each of the corners. This way I can make sure that the router plate can be perfectly level. This is kind of hard to see, but I removed the top portion of the table, and now I'm cutting a square out from underneath, and this way my plunge router can drop into that second deck area. After I marked out a hole location for my router, I used a countersink bit. This way I can get the machine screws flush with the top of the face. One of my favorite parts is when you peel off the plastic of the plexiglass and you see how clear it is. I only had 5 machine screws at the time, so I only put a few screws in just to check the fit, but later on in the video I add more screws to support the router to the faceplate. Once the faceplate is on, I use a spiral upcut bit and slowly plunge into the middle so I can find out where the center is. From there I use a hole saw to finish it out. Now that the router plate was done, I could work on the fence. To make the fence, I just taped these 2 boards together and then I cut a square into them with the jigsaw. I used brad nails to secure the 2 pieces together, and then right after that I tried to cut 45 90-degree pieces off and nail them in, and they instantly split. So later on in the video I come back and I put angle brackets on. Here is the 3D printed dust collection that I designed and 3D printed, and to secure it to the fence I just use screws. In order to get the router fence to move and slide and lock down in place, I'm just going to be using T-Trex. From what I read online, the best finish for MDF surfaces is shellac. I put 3 or 4 coats on, and it creates a nice hard surface, and sanding in between coats makes a huge difference. It makes the surface super smooth, and it's a pretty good finish overall. Here I'm just pulling off all the painter's tape. I didn't want to get all that sticky shellac all over my new T-Trex. To give my router fence some more support and to make sure it always stays at 90 degrees, I 3D printed some brackets and screwed them in place. In order to secure the fence to the T-Track, I designed a 3D printed knob that can fit a 1/4 inch hex nut, and that way I can secure it down tightly. So I don't know why I decided to do this step last, but now I'm just putting in all the shelf supports so that I can slide all the shelves into place. So the last thing I wanted to add to this miter saw station was a stop block. It has a little ergonomic finger hold so you can easily slide it back and forth. It also has rails on the bottom of it, so that way it always stays perpendicular to the T-Track, so it's always at 90 degrees. So here is the first test of the brand new router table. Right now I just have a 3/8 inch roundover bit, and it works extremely well. The 3D printed dust collection works super well. Just for a test, I put a little sawdust on the table and I slowly brushed it in, and you can see the dust collection sucks it up super fast. So for any of you guys that actually own this specific miter saw, you guys know firsthand that this saw is extremely long. I think it's one of the longest miter saws like on the market, if I'm not mistaken, but I think when fully extended from the back to the front, it's roughly like 3.5 feet. So when it comes to miter saw stations, there's not a whole lot of good configurations that you can do that are ergonomic. So that's why I designed this miter saw station on wheels. So, you know, I have these studs back here, so it's kind of hard. So you're probably like wondering, how do I cut my angles? And that's why I made it on wheels, because I can just pull it out, and then I can cut 30°, 45, make my cut, and whenever I want to go back to my straight cuts, I can just put it back and roll it back into position. Alright guys, I have finally gotten all my stuff put away. I couldn't be more happy with the way it came out. If you are interested in building this for yourself, I do have plans on my Etsy page linked down in the description below. I hope you guys enjoyed this video, and please be sure to like and subscribe.